In a previous video, we showed that if y is equal to a times x to the power of b, then if x changes by some factor, call it c, then y will change by a factor of c to the power of b, where b is that same power as that right here. So in this video, I want to do a few examples of this. For example, the kinetic energy of an object is proportional to the square of the object's speed. So b is equal to 2. Let's use relational reasoning to solve the following problem. An object has a kinetic energy of 5 joules. What would its kinetic energy be if its speed were tripled? So we're changing the speed v by a factor of 3. Therefore, the kinetic energy must be changing by a factor of 3 squared, that is by a factor of 9. So the kinetic energy will be 9 times what it was, and 9 times 5 joules is 45 joules. Let me do that again just a little more slowly. The speed v changes by a factor of 3, so the kinetic energy must change by a factor of 3 squared. 3 squared is 9. So the kinetic energy is now 9 times its original value of 5 joules. So 9 times 5 joules is 45 joules. Note that we didn't need to know the actual speed to solve this problem. We didn't need to know the mass of the object to solve this problem. All we needed to know was the form of the equation describing the relationship for the dependence of kinetic energy on speed and information about how the speed changed to get information about how the kinetic energy changed and to get a numerical answer. Let's do another problem with kinetic energy, but let's change things around a bit. An object has a speed of 10 meters per second. What would be its speed if its kinetic energy were doubled? The first thing we need to note is that we're being asked in this question how changes in the kinetic energy will impact the speed. But what we have our equation written as is to get the kinetic energy in terms of the speed. We want to turn that around. So let's solve this equation for the speed. So we can multiply both sides by 2, divide both sides by m, and take the square root. And here's what we get. The speed is the square root of the quantity 2 times the kinetic energy over the mass. We note that taking the square root of something is the same as having that thing to the half power. So we'd have 2 times the kinetic energy divided by the mass, all of that to the 1/2 power. We can separate it out, and so we get that the speed is equal to stuff times the kinetic energy to the 1/2 power. So we're now in a position to use the fact that if x changes by a factor of c, then y changes by a factor of c to the b. In our rearranged kinetic energy expression, we have that the speed is proportional to k to the 1/2 power. So if k changes by some factor, v will change by that same factor to the power of 1/2. In our specific problem, k is doubled, so that means it changes by a factor of 2. So the speed changes by a factor of 2 to the 1/2 power. And 2 to the 1/2 power is the square root of 2. So the speed is now going to be a square root of 2 times its original value of 10 meters per second, which is about 14.1 meters per second. Notice that we were able to get a numerical answer without knowing actual numbers for the kinetic energy or the mass of the object. Finally, keep in mind that depending on your actual problem statement, sometimes you have to take your original expression and rearrange it before you can more easily do the relational reasoning. Okay, thanks for watching.